can apply linear systems to real-world applications in order to compare various options of purchasing items. Okay, so the applications that we're going to look at in this video are specifically related to comparing options. So whether that's with a cost of, like, let's say, a taxi, a company that's selling something, and it's going to be something where we would be able to represent the options of what we are comparing with a linear relation with a line. So we would have a base cost and then like a cost per amount of something. Okay, so first I'm going to kind of walk through the steps of how we will set this up, and then I will show you an example. When you are using linear systems to solve an application or to solve a real world problem, the first thing that you always need to do is you need to have a let statement to define your variables. Okay, and so what this means is you are going to be clearly stating what variable represents what. So you can use x and y, right? Those are what we typically use for an equation of a line. So you would say maybe like let x, maybe we would say let y be the total cost, and let x be the number of items. Okay, so that would be an example of a let statement to define your variables. You could say maybe let y be the total cost and let x be, like, it could be like the number of kilometers. Like, let's say you're looking at a question with a taxi and there's a base rate that they charge as well as a fee per kilometer. Okay, so depending on the question, you'll get more specific with your variables here, but this is just sort of an example for what that would look like. So you're always going to write let, and then you'll have two variables. Okay, that's the important thing to remember, is that there's always going to be two variables. Okay, because when we're dealing with linear systems, there are two variables, x and y, and we'll see kind of in some examples later on that you can use different letters if you would like to as well. It's just a little bit more straightforward to use x and y because that's what we are used to with graphing. Okay, so once you set up your variables and define what they're going to be, you're going to create two equations. And these will typically be in y equals mx plus b form, and you can create them based on the information in the question. Okay, so like I said, sometimes or often b is going to be like your base amount or like your initial fee, and then m, the value that you put in for m, would be like the cost per amount of something. Okay, so maybe you're talking about like having somebody come paint your house. There's an initial fee of X amount of dollars, and then you pay an additional amount per hour that they spend working. Okay, so the B value, your y-intercept, would be that initial fee that you pay regardless, and then the M value, your slope, would be the charge per hour. Okay, so that's just kind of a few different hypothetical situations. We'll look at an actual concrete example in a moment. So once you have that set up, you will have a linear system. Okay, so two equations, both with two variables, that makes a linear system. So you can solve with either substitution or elimination. Because this is the types of examples, typically both equations are in slope-intercept form. Substitution is usually the most obvious method to choose, but you can use elimination as well. Either is fine. And then what you need to do is you need to interpret your results. Okay, so you're going to obviously get a point of intersection from solving the system. So that is going to tell you where both options are the same. Okay, so let's say you were comparing, I don't know, like a tattoo artist, and again, you pay like a flat booking fee, and then you pay an hourly fee. If we are comparing two different tattoo shops, and we set up an equation here, and we solve the point of intersection, that would tell us how many hours of work you could get done for the same cost at both shops. Okay, so like let's say you ended up getting X is 6, then that would mean if you're having a 6-hour long tattoo, it doesn't matter which shop you pick because you'll pay the same at both. But typically one is going to give us a better option than the other. So what we look at then is the equation with the bigger slope, or the steeper slope, is going to be the one that has the bigger result. Okay, so bigger cost if that's what your y variable is representing, bigger amount if that's what your y variable is representing. Okay, so whatever one has the bigger slope will have the bigger result after that point. So in some cases that's a good thing if you're looking for something that gives you the best, like the biggest output. In some cases that's not the best if your y variable is cost. So it just depends on the situation. Okay, but that's the key thing about this sort of question, is that we're going to interpret our results to be able to make a decision about which option we should choose. Okay, so if I look at this example here, it says Bob the builder is comparing two rental companies for a bulldozer. So there's company 1 is called Mighty Machines, and company 2 is called Yellow Construction Rentals. Okay, so Mighty Machines charges $400 upfront, like as a flat fee, plus $18 per hour. Yellow Construction Rentals costs $600 upfront as a base fee, plus $13 per hour. So we want to help him decide which company he should choose. Okay, so step 1 is going to always be defining our variables. So I'm going to have a let statement, and I'm going to say let y be the total cost. Okay, in this case that's what that's representing, because I'm looking to see how much it costs to rent the bulldozer. So that's what I'm looking for, is the total cost, and then X is going to be the number of hours worked or rented for. Okay, so now I'm going to set up my two equations. So I would have Mighty Machines, I'm just going to call that M here. So my total cost is going to be equal to, so if we look at this, we want to set it up kind of like in a y equals mx plus b fashion. So my my slope, is my cost per hour. So in this one it's 18. So $18 per hour, $18 multiplied by the number of hours, plus that initial $400 fee. And Yellow Construction Rentals, I call that YC. I can set up a similar equation. So my total cost, Y, is going to be equal to my hourly rate times the number of hours. So $13 times X number of hours, plus my initial fee. Okay, so plus 600. Hopefully you will have worked with setting up equations like this in grade 9. If not, that's alright. It's pretty simple once you have done a few examples to kind of figure out how you're setting everything up. Okay, so now I have a linear system. I've got equation 1 and equation 2. And here I could use elimination if I wanted to. They're not in standard form, but that's fine because they're both lined up with my y variables equals x variable and numbers. Okay, so you could use elimination. It would just be a little bit different because you'd end up with 0 equals, and you would have to bring this x term to the other side. I'm just going to use substitution because that is my preferred method usually. Okay, so I'm going to let equation 1 equal equation 2 and figure out what my x variable is going to be. Okay, so I'll have 18x plus 400 is equal to 13x plus 600. Okay, because they're both equal to y, that's what my substitution looks like. Then variables on one side and my numbers on the other side. Okay, so I'm going to subtract 13x from this side and from this side as well to bring my x terms to the same side. So I will have 5x plus 400 is equal to 600. I'm going to subtract 400 here and subtract 400 here, so that I've got x's on one side, numbers on the other, so 5x is equal to 200. Then I am dividing by 5 here and here. Okay, so that I have just x is equal to 200 divided by 5 is 40. Then I'm going to go over here and I'm going to sub x equals 40 into, again, doesn't matter which equation, I'll just sub it into equation 1. Then I have y is equal to 18 times 40 plus 400. And then I'm just solving for y, so 18 times 40 is 720 plus 400 is equal to 1,120. Okay, so my point of intersection is 40, 1,120. Okay, so in the context of this question, what that means, we know that my x variable is the number of hours worked, so x is 40 hours worked, and y is my total cost, 1,120, so that's $1,120. Okay, so if Bob rents the bulldozer for exactly 40 hours, then he will pay the same price with both companies, which would be $1,120. Then I just want to take a look and see which slope is bigger. So Mighty Machines obviously has the bigger slope. Okay, so if we were to kind of just do a quick little sketch here, I'm going to show here, if something has a bigger slope, I'm going to have like my axis like this. Let's say 400 would be lower than 600. It doesn't matter if this is to scale necessarily. This is going to be like this, a steeper line. 600, let's say, is up here, and this is not quite as steep. Okay, so let's say this one is yellow construction. This one is Mighty Machines, just so you can kind of visualize what's happening here. So what we can interpret then is if we are renting for less than 40 hours, right? This is my point of intersection, so this is when my x variable is equal to 40. So if Bob is renting for less than 40 hours, then this line is cheaper, right? The Mighty Machines option is cheaper. Whereas if he's renting for more than 40 hours, then Mighty Machines is more expensive, right? That is, in this case, we'd say Yellow Construction Company is cheaper. Okay, so that's, if it's helpful for you to draw a picture every time, by all means, please do that. But typically you can just look and see which slope is bigger. Okay, so we would say, therefore, Mighty Machines is cheaper for less than 40 hours. Okay, and then Yellow Construction Company is cheaper for more than 40 hours. Okay, so in these types of questions, typically when we are weighing options, there will be some conditions, right? This option is cheaper when this is happening. The other option is cheaper when this is happening, because that's kind of how things work in real life as well. Okay, so your point of intersection is when they both cost the exact same, and then you interpret the results based on which slope is bigger.